Hello, everyone, and welcome to Calculus. Today we are going to be studying integral as net change. This is actually going to be a super familiar topic to you. We're going back to SVA, how distance, velocity, and acceleration are related using derivatives and integrals. For each of the following, the velocity function is given in meters per second of a particle moving along the x-axis. And you're going to do all three parts of this. But before I even read the question, I always just start with, if this is the velocity, then the acceleration is going to be the derivative, which would be 12t minus 18. And its position at any time, which you can call s or you can call x. I'm using x just because this is a horizontal distance because the particle is moving along the x-axis. Sometimes when it's a vertical something, it's going up in the air. I like to use h for height, but it doesn't really matter. So I'm going to integrate velocity to get that, which would give me, I'll do it off to the side here, integral of 6t squared minus 18t plus 12, which would give me 6t cubed over 3 minus 18t squared over 2 plus 12t plus c. So I'm going to go ahead and fill that in here as 2t cubed minus 9t squared plus 12t plus c. And if we knew at any point what the value of x was at any given time t, then we could find c. And it actually does tell us that later. But my point is, I've got my three equations, and the goal is always going to be to know which equation to use for which question. So the first part says determine when the particle is moving to the left, to the right, and stopped. You need to recognize this question as talking about velocity. Moving to the right is positive velocity, moving to the left is negative velocity, and stopped is zero velocity. So I'm actually going to break my paper down into 3 sections just to keep it organized. You might want to do the same. This will be part A, part B, and part C. So I don't need the work that I've already done with the 3 equations. I'm going to stick straight with the velocity equation. I'm going to go ahead and start factoring it because I know I want to set it equal to 0. So 6 times t squared minus 3t plus 2, 6 times t minus 2 times t minus 1. So where is the velocity equal to 0? At t is equal to 2 and 1. So what is it doing the other times? You can make a sign chart. A lot of times we've made a derivative chart or a function chart. This is the derivative of x, but I'm just going to label it v. And I know that here at t is equal to 1, the velocity of 1 is 0. And at t is equal to 2, the velocity at 2 is 0. Well, if the velocity isn't 0, it's either positive or negative. Really easy to determine. I'm going to put a 3 in here, which is beyond that point. And if I put a 3 in, this is positive, and this is positive, and a positive times a positive makes a positive. This means that the particle is moving to the right. Now, if I put in a number like 1.5, 1.5 would make this factor positive, but this factor negative. And a positive times a negative would make a negative. The 6 doesn't matter because it's positive. So this indicates that the particle is moving to the left. And if I put in a number like 0, 6 times negative 2 times negative 1, because if t is 0, I get a negative times a negative, which is a positive, which again, we're talking about its velocity, and positive velocity means that the particle is moving to the right. So the question was, when is it moving to the left, right, and stopped? So it's moving right on the interval from, now watch this, even though I could just say from negative infinity to 1, I'm actually going to say from 0 to 1 because time can't be negative. It's moving to the left from 1 to 2, and then it's moving to the right again from 2 to infinity. It is stopped at t is equal to 1 and 2. So I've answered all of question A just by using the velocity equation. Question B says find the dark particle's displacement. Keep in mind that displacement is the difference between where you start and where you end. So for part B, I'm only talking about the interval from 0 to 2. So I'm going to start at whatever position it is at 0, and I'm going to end at s of 2. So they did give me something. They told me that s of 0 is equal to 3. That was given. So I really just need to find s of 2. So the question is, how do I find s of 2 if I don't have the entire s equation? I need to find that c first. So they gave me a value that will allow me to find c. So x of t is equal to 2t cubed minus 9t squared plus 12t plus c. I'm going to plug this in. 3 is equal to 0, 0, 0, 0. I love it when this happens. So c is equal to 3. Be careful. Sometimes they will give you the opposite. S of 3 is equal to 0. And you're so used to plugging all those zeros in, you'll do it that way anyway. But it's only if the t or the x is equal to 0 that you get to enjoy that. Okay, so here's my actual velocity, or my actual distance equation. 2t cubed minus 9t squared plus 12t plus 3. So what is the position at time 2? It's going to be 8 times 2 is 16, minus 9 times 4 is 36, 12 times 2 is 24, and then plus 3. So x of 2 is going to be, what does that come out to be? 7. But they don't want that. The question asks for find the particle's displacement. So the displacement, this is a huge distinction. Displacement is going to be s of 2 minus s of 0. So it's going to be 7 minus 3, which is 4. So that means that even if you don't know where it starts or where it ends, I know that it moves 4 to the right during those 2 seconds. Overall, maybe it went forward and then back, but we know that it moved 4 to the right overall. So I want to show you something that I'm hoping will make a connection for you. You do not have to write this down. I mean, you can if you want to. I'm going to use my little section C over here temporarily. Okay, this is just an extra note. So another way that you can find the displacement is always going to be equal to the integral of the velocity from A to B. So watch this. If I go from 0 to 2 of my velocity equation, 6t squared minus 18t plus 12, then I will get 2t cubed minus 9t squared plus 12t. Now, since it's a definite integral, there's no plus c, and I go from 0 to 2. I plug in the 2, and I plug in the 0, and I'll end up with 4. Why does that also work? That works because you're finding just the relationship, just the distance underneath that portion of the curve. When you find C, which is great, then you can do both problems separately. But in this case, if you had found C, there'd be a plus C for the 2, but then you'd subtract that same C for the 0. And so this is another way to think about it. Sometimes people understand the blue way first, but eventually it'd be great if you could understand how displacement is related to velocity. All right, I am going to erase that so I can do part C. So screenshot it if you want it. Okay, I actually didn't finish part B. I just realized there's there's a part 2 of part B. And that says, what is the particle's final position? So at t is equal to, sorry, I did not want to write there. At t is equal to 2, at t is equal to 2, what did we get? 7. X of 2 is equal to 7. You might be thinking, why did they ask the question in that order? We had to find its final position in order to do displacement. But remember, the person that just did it the other way would have found the displacement. So they went from 0 to 2 of the velocity, and they got 4. And for them, they're going to say, well, if at s of 0, I'm at 3, and then I move 4, my final position must be 7. So they would have done the question in the opposite order. Another way to think about that, here comes fundamental theorem of calculus. You ready for this? Hope I'm blowing your mind. I hope it's all fitting together. The fundamental theorem of calculus says that if you have the integral from 0 to 2 of v of t, then that's going to give you normally capital V, but we're going to call it x of t, or x of 2 minus x of 0, x of 2 minus x of 0. I put the x of 0 on the other side, and I get x of 2. So x of 0 is 3, the definite integral was 4, and we get x of 2 is equal to 7. So many ways to think about the same concept. So I hope some of that is, one of those ways is making you go, oh, I get it now. Okay, so part C says find the total distance traveled by the particle. So let's actually make the number line and look at what this particle is doing. Here's 0, 1, 2, 3, 4, 5, 6, 7. We know that at t is equal to 0, it's here. We know that it ends up here, but it didn't just make a straight shot because it wasn't moving to the right the whole time. Look over here. We know that it was moving to the right starting at time 0. It was already moving to the right, but then it turned around and it moved left. And we actually don't care that it ended up moving right again because we're stopping our information at 2. So if it moved left for a while, then what must have happened is it must have started here. It must have gone beyond the 7 and then come back because we know it ended up moving left and ended up there. So in order for us to figure out how far it went total, we need to find how far it went during the first second and how far it went during the second second. And how can we figure that out? Integration. Integration of velocity from 0 to that 1 second mark, because that's the whole time it was moving right. This answer should come out positive. And then we want to know what it was doing from the 1 second to the 2 second. I know it was moving to the left. I don't know how far, but I am going to put absolute values around this because this number is going to come out to be negative because it moved backwards. So its distance was negative, but I'm going to take the absolute value of it so I can add these two numbers together. So you can go ahead and do that integral on your own. You can use your calculator if you want to, but this is going to come out to be 5. This is going to come out to be -1, but since it's absolute value, my final answer is 6. So it moved 6 meters altogether. Okay, let's try another one of those. Ooh, this time we got a trig function. Always makes it harder, but we're going to set it up the same way. By the way, you can't see the directions on the screen anymore, but the s of 0 being equal to 3, notice that applied to all problems. That's in the main directions. All right, so we've got part A, part B, and part C. Part A says determine when the particle is moving to the left, right, and stopped, which is all about velocity. So you need to figure out when this velocity is equal to 0. Now you're used to factoring and doing stuff like that, but you can't in this case. So this is going to bring us back to really long ago. We're going to divide by 6. This is some serious pre-calc here. And now we just have sine of 3t. So I don't know if you remember this, but what we used to do was we just solved it as if that 3 wasn't there. When is sine, just in general, equal to 0? So sine is equal to 0 at 0, at pi, at 2 pi. Oh, I don't actually need to know all that. I'm just going from 0 to pi halves. So it's equal to 0 just as 0. We don't even care about those. Or do we? We do need them. Okay, this is the mistake that so many kids make because this is 3t. Then to actually find t, we get 0, pi thirds, 2 pi thirds. Okay, so this was also a common mistake in pre-calc, was to look at the interval first and decide the answers before dividing by 3. You have to divide by 3 and now look at the interval. So on the interval 0 to pi halves, the 2 pi thirds is out of our interval, but the pi thirds is there. So now I know that at time is equal to 0 and time is pi thirds, the velocity is equal to 0. Velocity at pi thirds is equal to 0. What is it doing in between? Well, hopefully you can just picture the graph of sine. Sine is positive, and then after it crosses 0, right, sine, it becomes negative. And then we're going to stop it at pi halves. So our answer is that it's going left, or let's do right first because that's positive. It's going right on the interval 0 to pi thirds. It's going left on the interval from pi thirds, and only because the interval stops, I'm going to say to pi halves. It actually went all the way till 2 pi thirds. And it is stopped at t is equal to 0 and t is equal to pi thirds. That's the answer to part A. By the way, notice I'm using open parentheses. I'm not bothering with brackets. It doesn't really matter because right at pi thirds, it's not moving left or right. It's stopped right at that moment. So the parentheses are fine. All right, part B, find the particle's displacement. So this time I'm going to do it the second way. Displacement is always just going to be the integral of velocity. So we're going to go the displacement from 0 to pi halves. Because this is a definite integral, you are welcome to plug it into your calculator to figure it out. But on the outside chance this is asked on a no calculator section, it'll give us a little chance to practice this. So we're going to go from 0 to pi halves of 6 sine of 3t. I'm going to let u be equal to 3t, which would mean that du is equal to 3 dt. I don't have a 3 dt, so I'm going to put, I actually don't even have a dt. You have to put that in yourself. So I'm going to put in a 3 and a 1/3. And that's going to give me the 6 and the 1/3 make 2 times the integral. Now don't write the 0 in the pi halves because this is no longer the correct limits once I switch this. So now it's just going to be sine of u du. Much easier integral to handle, right? So the integral of sine is cosine. I think about that and think derivative of cosine is negative sine. So this must be negative. Or you can use your appendix if you have it. And then I put it back, -2 cosine of 3t from, now I can put my correct limits of integration now that I'm back with t. It's still a hard problem. -2 cosine of 3 pi halves minus, I'm just going to move this line over a little bit, minus -2 cosine of 3 times 0. So all the pi halves for cosine are always 0. That's where cosine rises and falls. So cosine of 3 pi halves is 0. And then this becomes +2, and cosine of 0 is 1. 3 times 0 is 0, and then cosine of 0 is 1. So my answer is 2. That's its displacement. 2 meters is the displacement. So where does it end up? Well, since you start at 3, remember in the original directions it said s of 0 is equal to 3, then it ends at 2 plus 3 is 5. S of 2 is 5. That's where it ends up. Part C, you can look on your own paper, it says find the total distance. So remember, integral means area under the curve, or in SVA problems, means area or it means displacement. If you ever want total distance, you need to have all separate integrals. So the positive ones and the negative ones have to be separated. So the total distance is going to be whatever you get from 0 to pi thirds. That should already come out to be positive because it was moving to the right. But then from pi thirds to pi halves, it's moving to the left. And if it's moving to the left, it's going to be negative. So this is going to come out to be negative. So I have to take the absolute value to make it positive. All right, I won't torture you with another hand-done integral. We did it with part B because I wanted to review it. But I will put the answer in now. If you do this on your calculator, you'll get 4. If you do this on your calculator, you'll get -2. So you take the absolute value and you'll get a total of 6 meters, which ironically is the answer as the last one. Same as the last one. Okay, let's do number 3. Number 3, let's break it down into 3 sections again. So we have part A, part B, part C. So this velocity, really weird equation, right? We're going to set this velocity equal equation. Like our trig one, there's nothing to factor. It's just a little bit different. So instead, I'm going to square both sides, and I get 0 is equal to 4 minus t. And then I add the t to the other side, and I get 4. So it is stopped at t is equal to 4. That's the only time that the velocity is equal to 0. So what is the velocity doing the rest of the time? You still can do it the same way. You can still just check a point in the interval. So if I plug in a 2, then I get 4 minus 2, the square root of 2 is positive. So this has a positive velocity the entire time. So it is always moving right. You can write that. They'll accept that. Always moving right. Or you can say it's moving right just traditionally on the interval from 0 to 4. Either way. Part B says find the displacement for the given time interval. So its displacement is going to be its distance wherever it's located at 4 minus. So make sure you understand this. This is where it is located at time is equal to 4 minus wherever it's located at 0. So we don't know either of those, but we do know that this thing is always moving to the right. So can we find that? Sure. S of t is going to be the integral of v of t. So I'm going back and I'm doing this yet a different way. You're going to find the way that works for you. So the integral of 4 minus t to the 1/2, I am going to let my u be 4 minus t, and my du is equal to negative dt. I don't have a negative, so I'm going to add a negative to both sides, and I get negative integral of u to the 1/2, which is negative u to the 3/2 divided by 3/2, which is negative 2/3 u to the 3/2. My final answer, S of t, is negative 2/3 4 minus t to the 3/2. I can use that to find my position at 4, which is going to be, when I plug in a 4, then 4 minus 4 is 0. So it started, this whatever it is, actually started at t is equal to 0. Its position was 0. Oh, that's t of 4. At 0, ooh, this is going to be tough. 4 minus 0 to the 3/2. That's going to give me negative 2/3. So remember what this means. The 2 means square root, and then the 3 means cubed. So it's not as bad as it looks. Square root of 4 is 2. 2 cubed is 8. So negative 16/3. So at t is equal to 0, its position is negative 16/3. So it's way back here. So if here's 0, 1, 2, 3, 4, 5 1/3, that's where it is. Negative 5 1/3 at t is equal to 0. But then we know that it reaches 0 after 4 seconds. So what is its displacement? That's its position at s of 0. This is its position at s of 4. So if you do s of 4 minus s of 0, you'll get 0 minus negative 16/3, positive 16/3. It moved forward, which makes sense. This is where it was at 0. This is where it is at 4. It moved forward 16/3. It does ask for what was its final position. So this answer will work for that. Its final position was 0. Okay, so I just have to keep making this connection. You can skip this little part if you're like, I got the connection already. But just think about this. Velocity, if you integrate it, you're going to get distance. So if you integrate specifically from 0 to 4, you're going to get s of 4 minus s of 0. So if you ever want to know displacement, you can just do the definite integral of velocity, and it is going to give you displacement. Now, will it give you total distance? It actually sometimes can. When is the displacement the same as the total distance? When is the displacement the same as the total distance? Are you thinking, or are you just waiting for me to tell you? You guys have to think even though you're watching a video. So the displacement is the same as the total distance when it doesn't change direction. When it doesn't change direction. So for this one, it started at negative 5 1/3, and it just moved to the right. It was always moving to the right the whole time. So its displacement and its total distance were both 16/3 or 5 1/3. And I think we're still in meters. Okay, so part C was a nice easy one on this one. Okay, last one of this type, number 4. You should really try it on your own. In fact, so much, I think I'm just going to give the 3 answers. So this one is always moving to the right from 0 to 3. It is stopped at t is equal to 0 when it first starts. Part B, its displacement is 1.151, which is, by the way, natural log of 10 over 2. And its final distance, x of 3, is equal to 4.151. And part C, because it was always moving to the right, its final distance is the same as its displacement. So it's still this, which is 1.151. Okay, you can screenshot that if you need to. And now I'll go ahead and I'll do it for people that would like to see it out. And keep doing my little parts A, B, and C here. Part A, part B, part C. So part A asks you for when the particle is moving to the left, to the right, and stopped. That always deals with velocity. So notice I tried to give you 3 very different problems, actually 4. The first one was traditional, where you get to factor, but then sometimes you're going to have a trig function, sometimes you're going to have a square root, and now we have a rational function. But when I clear the fractions, 1 plus t squared, 1 plus t squared, I literally just get 0 is equal to t. So that's when it stopped. It stopped at t is equal to 0. Since it doesn't stop again, that means that this will be the same value through this whole entire interval. I can pick any number, so I'm just going to pick 2. If I put a 2 in, I get 2 over 5, which is positive. So it is always moving to the right. Always moving to the right. Part B asks for its displacement, which means its position at 3 seconds minus its position wherever it started. So this formula is for velocity. We need the formula for its position, which we could integrate. But since I'm going to jump straight to that step, then this from 0 to 3 will give me position of 3 minus position of 0. And that will save me the trouble of doing the whole find C thing. When there's a definite integral, there's no finding C by plugging a number back in. So I do want to do this one by hand from 0 to 3 of t, because it's a pretty tricky integral, t squared. I don't know if you're looking at it and you already have an idea, or maybe you saw the answer and that gave you an idea, but it is going to end up having a natural log. So u is equal to 1 plus t squared. That's what makes this one so tricky. And then du is equal to 2t dt. I don't have the 2, so I'm going to go ahead and add a 2 and a 1/2 to my problem. And then I'm going to rewrite it without the limits of integration as just du over u. This is a very special integral. It is the natural log. So 1/2 the natural log of the absolute value of u. 1/2 the natural log of the absolute value of 1 plus t squared. Now, you can get rid of the absolute value if you want to at this point, because 1 plus t squared will always be a positive number. It would not be wrong to eliminate it, and not even bad since there's a lot of lines going on here. But this is going to give me 1/2 the natural log. If I plug in a 3, I get 10 minus, I'm going to do this again, I'm going to erase this line, minus 1/2 the natural log of 1, absolute value of 1, which is just 1. And you do have to know this fun fact here. Natural log of 1 is 0. Memorize that. Know it. Just like you know that anything to the 0 power is 1, it's the same rule in reverse. The natural log of 1 is always going to be 0. Graphically, when you're at 1, it looks like this. The natural log of 1 is 0. Okay. So since this is equal to 0, my final answer for displacement is 1/2 the natural log of 10. which is approximately 1.151. The second part of B says find the final position. So they actually want to know x of 3. The final position is x of 3. So let me just do a little review of my fundamental theorem of calculus here. If I write it this way, then I can say, well, they gave me that x of 0 is 3. So I can add that 3 to the other side, and then 3 plus the integral from 0 to 3 of v of t is equal to x of 3, meaning your starting spot plus your displacement will give you your final position. And since we just figured out that the displacement was 1.151, x of 3 must be equal to 4.151, which was the second half of the question. Part C, you're going to love this. Nice and easy. I'll draw my line, but I don't need it. Its total distance equals the displacement. Why? Can you answer this question? Why? Because it never changed direction. Because it never changed direction. So the total distance is equal to 1/2 the natural log of 10, which was approximated by 1.151. Okay, so we have a couple word problems to do, just to put it in some context for you. From ground level, a projectile is fired straight upward with a velocity of 90 feet per second. So everything's about interpretation. Everything's about you recognizing that the velocity at 0, at the moment it was fired, was 90. So they've given you a point. The points are always used to find c. The acceleration due to the Earth's gravity is negative 32 feet per second. It's negative because gravity is forcing us back down to Earth. So I personally, I know I said this right in the beginning and then didn't do it for all three problems, but if I have something like this, I definitely start with just getting my equations. So acceleration, there's nothing else on it except negative 32. That's it. So my velocity, if I integrate, is negative 32t plus c. But since I know that the velocity of 0 is 90, if I put a 0 in there, 90 is equal to negative 32 times 0 plus c. C is 90. So I'm going to replace that with velocity at time t is negative 32t plus 90. A little bit better equation. And then I integrate that for my position. Actually, I'm going to use h this time. Don't want you to be stuck on has to be s or it has to be x. It's its height at any time is negative. Now when I make that t squared, I'm going to divide by 2. So it's going to be negative 16t squared plus 90t plus c. Now in order to get that c, I need to know its position at some time. And they don't like to just shout this out to you. You're going to have to think about it. From ground level, that means its height at time 0 was 0. So of course, if I plug a 0 into there, h of 0 is 0. So 0 is equal to negative 16, 0 squared plus 90 times 0 plus c. C is just 0. So again, I'm going to cross this one out, and I'm going to replace it with a slightly better one without a c, because c is 0. Okay. Another way to think about it, the c in the velocity equation is always your original velocity. In the height equation, c always represents the original height. Okay, so I've got my three equations. I didn't even read the problem yet. I just like to have my three equations, and then I just ask myself, which one do I need? So for part A, what is the velocity after 3 seconds? See, now I can just jump straight to the answer. Oh, they want to know the velocity at 3 seconds. I've got an equation for that. Negative 32 times 3 plus 90. This is negative 96. So negative 6. My units are in feet, and because it's velocity, it's per second. Acceleration is seconds squared, and of course distance is just feet. But you could write that over here. Feet per second squared, feet per second, and just feet, if that helps you. Okay, part B. When does it hit the ground? So the question is asking about time, but what do we use to answer it? Its height. Hitting the ground would be h of something is equal to 0. Or is it velocity? When it hits the ground, does it have 0 velocity? So that's a common mistake, is for people to think that when it hits the ground, it has 0 velocity. Well, it does after it hits because it stops, but it could hit the ground with a lot of force. So when it hits the ground, its height is 0. So we're looking for the time when its height is 0. So I can take this equation, h of t is equal to negative 16t squared plus 90t, and I want to know where the height is equal to 0. Well, if I take out the t, then I get negative 16t plus 90, and there's two answers. Either t is equal to 0, or t is equal to, and I'll do that for you, 5.625. And of course, we already knew this one. We knew that it was launched from the ground. So this is when it's launched, and then this is when it lands. And it follows a parabolic path. So when does it hit the ground? At 5.625 seconds. Part C. What is the net distance? So net distance is always the integral of the velocity over the given time. So from 0 to 5.625, I can tell you what its net distance was. When it hits the ground, its total distance, you're going to have to separate the integrals based on positive and negative. So they have to be done separately. Now, before I actually do this, do you already know the answer? What is its net distance? Here's 0 seconds. Here's 5.625 seconds. It goes up, and then it goes down. I guess we used h. It's 0. You don't even have to do the math. It had better come out to be 0. But for part D, its total distance, I'm going to need to break it into two separate integrals. When it has a positive velocity, right? And then when it has a negative velocity. So what is that point? Well, we've actually done that point quite a bit. What is special about that point? What is its velocity right there? Velocity means slope, right? So it has a positive slope, positive velocity, and then it gets slower and slower. Notice its velocity, its slope is less steep. That's because acceleration is, the gravity is working against it. So even though it was fired off at 90, so its original slope was 90, now its slope is almost 0. And then right at the top, the velocity is equal to 0. So I'm going to just go back and figure out when the velocity is 0. When is the velocity equal to 0? So in all these other problems, they started with that. They asked you, tell me when it stopped. But now they didn't make that so explicit in the word problem. It's going to be your job to say, oh, I need to know when the velocity is 0 so I can break it up into two parts. So the velocity is equal to 0 at 90 divided by 32 is going to give me 2 point. So I guess I'll do the little math here. Don't want to lose anybody. So t is equal to 2.8125, which makes sense. That is exactly half of my 5.625, right? We expected it to be at exactly half. So I'm going to do the integral from 0 to 2.8125. It's gaining distance. This should come out to be a positive number, but this one will come out negative from 2.8125. Sorry, that looks like a 12 there. I'm just going to erase it. Up until 5.625. Of course, you're welcome to do those on your calculator. There's nothing tricky that makes me want to show them to you. So the total answer should come out to be 253.125. Make sure you've got your units. It is in feet. Okay. Number 6. So the purpose of number 6 is to show you that it's not always going to be about distance, rate, and time. This one says the fuel consumption of a diesel motor between weekly maintenance periods is modeled by the function C of t is equal to 4 plus 0.001 t to the fourth gallons per day. That's going to be the key. So if they've given you gallons per day, they've given you the rate. So C of t is the rate of the consumption, okay? Which means that if you integrate C of t, right, then you'll just get gallons. So here's my different SVA. And of course, I could get the rate of the rate. I don't think I need it for this. How many gallons would be integral? Because it takes a rate and makes it into a whole unit. Just like meters, meters per second squared. If this is your rate, then this is your amount. And that's always going to work. So how many gallons does it consume in a week? Well, there's 7 days in a week of C of t. And I don't think that this is anything so spectacularly challenging that I'm excited to show it to you out by hand. So you can go ahead and use your calculator, and it will give you 31.361 gallons. Like I said, the main point of this one is to realize that if you're ever given a rate, you can integrate to find the amount. So it's not just SVA, it's any amount, any rate, and any rate of the rate. So maybe it's people. Maybe it's people per day. Maybe it's dollars. Maybe it's dollars per hour, okay? Or in this case, it was gallons and gallons per day. Last one. A pump connected to a generator operates at a varying rate, depending on how much power is being drawn from the generator to operate other machinery. The rate in gallons per minute, so right away, there's my V, at which the pump operates is recorded in 5-minute intervals for 1 hour as shown in the table below. How many gallons? So they gave me the rate and they want to know how many gallons. What am I going to do? I'm going to integrate. So they gave me the rate in gallons per minute, and they want the amount in gallons. I'm going to integrate. What am I going to integrate? I don't have a function. And here we go. I love calculus. All right, now we're going to bring the whole thing together. I want to integrate. I don't have a function. But integral means, I hope you're saying it in your head, integral means area. So I'm going to find the area under this curve. Here's time and here's rate. And we know that distance is equal to rate times time. But in this case, amount, actually, I'll just go ahead and change it to gallons, is equal to gallons per minute times minute. So if I have this rate, and if it was a perfect rectangle, I could do the gallons per minute times the minute, and I would get the gallons. Can I actually find that? Well, I'm going to estimate it. I'm going to estimate it using one of my rams or trapezoid rule or whatever we decide to do. So here's my time. Let's see, what do I have to get up to 60? So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. And let's see, it looks like I'm going from somewhere around 55, looks like the lowest, up to the 60s. So I'm just going to go like this. I'm just going to say 58, and then 60, and then 65, and then 64. It's really important to me that you do not spend too much time on these graphs. You're just trying to make them approximately correct. 55, 59, 60, stays at 60, 63, and then 63. So it's neat, right? Let's see. Did I start at 0? Okay, so let's go ahead and make this graph. So I need 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So I'm just going to kind of throw them on there. Let's say this is 58. Then this would be about 60. And then this would be about 65. This would be about 64. This would be back at 58, 57, 55, 55, 59, a little higher based on my other one. But you see how I'm not killing myself over this. 59, switch pens. At 45, I'm up to 60, stay at 60, and then my last two are at 63. Is this perfect? No, definitely not. But I'm going to use it so that I can draw my rectangles. So if this were actually the AP exam or an actual test by me, I would tell you what I wanted you to do. But obviously the easiest thing to do would be to use MRAM because I have the middle numbers. So I'm going to break this off at all of the, make it into just, even though there's 10 spots, into 5 groups. And that way, look, I can use this middle number to get MRAM. So this rectangle is a 10 by 60 rectangle. So 600 gallons in that first 10 minutes. And then this one, also 10, this is also a nice number. 10 times 64 is 640. 10 times 57, 570. 10 times 55, 550. So this one's higher. This is the first one I've had to extend this line, 600. And then also this one I'm going to have to extend the line because the midpoint is higher than the left side, 630. Okay. I could use left LRAM or RRAM, but obviously MRAM is going to be the most accurate. So if I add those up, I get 3,590 gallons. Okay. If you do want to practice your LRAM or your RRAM, because I used to make everybody do it when we were in school just to practice, it would be 3,570, and RRAM would be 3,595 gallons. Okay, if you wanted to practice those two. Just one little quick note before we go about AP. Unfortunately, they won't accept this as your work. Please, please, please make sure that you write 10 times 60 plus 10 times 64. If you do not show evidence of both addition and multiplication all the way, and they just won't give you one so long, then they will not give you credit for it. So maybe because I did it once and then it's implied, you could get a reader that's willing to take it up to the leader and say, hey, they definitely were doing that. But then they would say, yeah, but then they didn't show that they added them, which is crazy. I know it's a little tiny pet peeve of mine. So please make sure you show your work this way to get full credit. All right, that is it for this section. I hope you have a great day.